Good day, grade 11 students. We are now in our week 11 lessons, which is about logarithmic functions. So logarithmic functions are basic mathematical tools in a variety of phenomena involving physical sciences, engineering, economics, and medicine. In the past, logarithms are models used in computation involving very large or very small quantities in the field of astronomy, chemistry, physics, and engineering. This practice remained until the advent of scientific calculators and computers. Logarithmic functions are useful tools in volcanology and seismology. Specifically, the topic logarithms has applications in earthquake magnitudes, decibels, and acidity levels of earth substances. So we have here the pictures of some applications of logarithmic in real life. So much of the power of logarithms is their usefulness in solving exponential equations. So some applications of this include sound, that is the decibel measures, earthquakes, we are using the Richter scale, the brightness of stars, and chemistry or the pH balance, a measure of acidity and alkalinity. So that is the useful of using logarithmic functions and the exponential functions. So from our previous discussion, you learned that if a function is one-to-one, the function has an inverse which is also a function. So last time, matublanggin proved na nga si x sub 1 is equal to x sub 2. Therefore, there exists an inverse function. So you learned that exponential function f of x equals a exponent x, where a must be greater than 0 and a is not equal to 1, is 1 to 1, and therefore it must have an inverse which is also a function. This inverse function is called the logarithmic function with base a. So the inverse function of our exponential function, that is what we call the logarithmic function with base a. Okay, so we have here the definition of our logarithmic functions for x greater than 0 and a is greater than 0 and a is not equal to 1. Y equals the logarithm of x with the base a if and only if x equals a exponent of y. The function f of x equals the logarithm of x with base a is called the logarithmic function with base a. So we observe that every logarithmic function can be written in an equivalent exponential form, and every exponential equation can be written in logarithmic form. The equations y equals the logarithm of x with the base a and the x equals a exponent of y. So y here is an exponent, are equivalent. Okay, so they are just equivalent in form. So aton nga exponential can be changed into logarithmic form, and same also from our logarithmic, pwede ito sama change into exponential and exponential to logarithmic. So pwede na sila duwa change their form because they are inverses. Okay, now let's proceed to the difference between logarithmic equation, inequality, and function. Logarithmic equation, an equation involving logarithms. So we have here an example. The logarithm of 2 with base x is 4. Okay, so in our logarithmic equation, we are solving for a certain value of x so that both sides of the equal sign must be equal. In our logarithmic inequality, an inequality involving logarithms, so we are using here the inequality symbols. Suppose na siya mag-identify if it is logarithmic equation or inequality because of the symbol we are using. So we have here an example, 2 times the logarithm of the quantity 2x plus 1 with base 49 is less than or equal to 1. Now we have here the logarithmic function. Logarithmic function of form f of x equals the logarithm of x with base b, where b must be greater than 0 and b is not equal to 1. We have here an example, the g of x equals the logarithm of x with base 3. So sa dire, sa aton nga function, if we have here a certain value of x, then there's correspond g of x. So kung may kita may input, which is ang x, then may kita naga-corresponds nga output. So sa diri sa aton nga logarithmic functions, we are not solving for the value of x, but we are looking for its corresponding output kung may kita certain input. So a logarithmic equation or inequality can be solved for all x values that satisfy the equation or inequality. A logarithmic function expresses a relationship between two variables such as x and y, and can be represented by a table of values or a graph. So in logarithmic function, we can use this in representation by using graph. So sa graphing, you may use any application app, graphing applications sa inyong phone for graphing the logarithmic functions. Okay, so we have here a practice activity. Determine whether the given is a logarithmic function, a logarithmic equation, or logarithmic inequality, or neither. So we have here g of x equals the logarithm of x with base 5. So this is an example of logarithmic function. So kindly take note that 5 here is base, so dapat nakasub na siya. Dapat nakalog the logarithm of x with the base 5. So muna dapat i-itsura. Same also here, y equals 2 times the logarithm of x with base 4. So this is an example of logarithmic function. Still, it is a function. Since if we are an input, kung may value kita di ka x, then there's correspond value of our output. Okay, so we have here the logarithm of 4x with base. So automatic, kung wala di gani nakasulat nga base, that is considered as 10. So, meron siyang pinaka-common na log, which is ang base 10. So, we have the logarithm of 4x with base 10 is equal to negative times the logarithm of the quantity 3x plus 5 with base 10. So, this is an example of logarithmic equation. Next, we have here x times the logarithm of x with base 2 minus 1 is greater than 0. So we are using here the inequality symbol, so this is a logarithmic inequality. Next, we have here the logarithm of x with base 10 is equal to 2. So this is an example of logarithmic equation. Since if we have here the value of x, dapat both sides of the equation must be equal. Okay, so that's all. I hope you will be able to identify the difference between logarithmic equation, logarithmic inequality, and the logarithmic function. Okay, so that's all, grade 11 students. Thank you for listening, and if you have questions, kindly message me to our group chat. Thank you.